Okay, I'm going to be doing Codeforces round 617. I'm starting like 3 minutes late. I think I can just like simulate this. Wait, actually, should I do this greedily? I don't know if greedy works. I'll just see. Okay, we can calculate prefix sums of the coordinates. Then I need a map to keep up the prefix sums. So many. Okay. Print any of them, okay. Fight with the monster out of some terms. Okay, I think I process each fight individually. if I calculate the minimum number of techniques I need to use. So the health is within this range, then we win. If it's this range, then the opponent wins. So if the health is like here, then okay, I think I got it. Does the order actually matter? How does this work? Okay, this statement is a bit confusing, but I think I understand it. Oh, I think we can create a graph from this. So when you choose the minimum number of colors, I think this is finding the longest decreasing subsequence. Yeah, okay, it seems like it, so. This works, right? Yeah. Okay. I think, yeah, let's like update all edges to be at least g of j. way. Oh wait, there's no weight. Okay. Oh, I'll put the answer first. Actually, I need to check if the answer works. So okay, let's just get AC. Okay, great. I started 3 minutes late, so yeah, I could have gone in. I think I could have gone in first if I started earlier. But anyways, so starting with the first problem, array with odd sum. So we can choose any two index j in the array and set any index I to the value of a of j. Basically, we only care about the parity of the elements. So first we go through the array and we check if there exists an odd element in the array, which is h1, and if there exists an even element in the array, which is h0. And then we need to do casework on the parity of n as well. So if the length of the array is odd, then if the length of the array is odd and everything is just all the elements are even, then the sum is even, and the answer is no. But if there exists one odd element, then we can change all elements to odd. And since the length of the array is odd, the final sum will also be odd. So the answer is yes, if and only if there exists an odd element. And for when n is even, if all of the elements are odd or all the elements are even, then the answer will be no, because the length of the array is even, and an even number times any number is even. So in order to have an array with odd sum, we need at least one even element and at least one odd element. And then we can, for example, if we have an array like this, we have 2 even elements and 2 odd elements, and we want to change this into an array with odd sum, then we can simply just replace an even element with an odd element. So replace this 2 with a 3, and then we'll get an odd sum. That's basically it for problem A. For problem B, basically we don't want to waste any of our money when we use it, so we want to make it so that x is exactly divisible by 10 when we use when we buy something. So in my algorithm over here, basically if s is greater than or equal to 10, then I find the biggest multiple of 10 that's divisible by 10. I find the greatest multiple by 10, which is less than or equal to s. That's t times 10. Then I set t times 10 to x, and I subtract it from s, and I add x divided by 10, which is just t, back to s. And the answer increases by x. And the last case is when s is less than 10. In that case, you just have to use what we have left. And then, yeah. And this basically just sets s to 0, and then the loop will stop. For problem C, we can treat so we can treat the entire, we can calculate the prefix sums of the given string. So what I mean by that is that L will be equal to -1, 0, R will be equal to 1, 0, D will be equal to -0, -1, and U will be equal to 0 and 0, 1. And then when if I calculate the prefix sums for this, I will get so with the first element only, it'll be this, and when I add U, I get this. Then when I add R, I get this. When I add L, I get this. When I add L, I get this. And when I add R, we get this. So we basically just calculate the prefix sums of these characters. And then notice that if basically you want to find a substring such that the sum is exactly 0. And what we do is we find two, oh yeah, I should add 0, 0 in the front over here. So what we do is we find two elements in the prefix sum which are exactly the same, such as these two. These two are the same. So when we take the substring over here, which is RL, then we get a substring which sums to 0, which is what we want. And then since you want the smallest one, what we can do is we iterate from left to right, and then for each prefix sum we store it in a map, and then we keep track of the latest time that it appears. So here's my code. At the start, the prefix sum is just 0, and then this prefix sum of 0 occurs at index 0. Then I update the prefix sum based on the character, and then if this prefix sum has already appeared before, then I update the answer with the difference between the positions of the two prefix sums. And then I basically update the answer. Then I set the last occurrence of this prefix sum to the current index. And that's basically it. So for problem D, basically for every monster, we will calculate the minimum number of techniques we need to use so that we will get 1 point for that monster. So I'll calculate that value for each monster I, call it C of I, and then I'll sort the values of C, and then I'll take the values of C that are smaller first until I get to a sum of K. So how do you find the values of C? So we can work out some small cases. So if basically we'll take turns, and basically each round the monster's HP will decrease by A plus B. So first we take the remainder of the health of the monster with A plus B. Then if the remainder is 0, then we just set it to A plus B. And now we know that health is in the range of 1 to A plus B. Now, how many times do you need to skip? So if the health is in this range, then we don't need to skip any times. We can just hit the monster once, and then the monster will die. Then run if h is greater. So if h is from a plus 1 to 2a, then we need exactly one skip. The first skip subtracts the health of the monster by a, and after the first hit, the monster's health will become this, and then we don't need any skips anymore. So basically you can find a pattern here so that the number of skips is exactly h divided by a ceiling minus 1. And this is just my formula over here. Okay, so problem E. I'll go through the easy version first. So we notice that if there are two characters, such as E and D here, E comes before D here, but then since E is greater than D, that means that these two characters will have to be swapped with each other at some point in order for the stream to become sorted. So we know that the colors for these two indexes have to be different, which is shown in the output here. The first one is E is 0 and D is 1. So all you need to do is for each pair, such that the first element in the pair is greater than this, such that the first element in the pair is greater than the second element in the pair, we need to add an edge between these two elements, and then we need to check if we can color all of the elements using only 2 colors. And this is just bipartite coloring, and it's pretty standard. So we just check if for each pair, such that this is true, we add an edge, and then we just run bipartite coloring on it, and that's pretty much it. And for the hard version, the same thing still applies. If we have a character which comes before another character, but then it's greater than the character which is after it, such as E and D here, then it means that these two need to have different colors. So you might wonder why the answer is 3 for this case. Well, that's because of, okay, let me write this out first. That's because of E, D, and C here. Like E is great. All of these pairs have edges between them. So we know that these 3 must have different colors. So that's why you can't use only 2 colors on these. And in general, if we have a sequence of indexes such that a sequence of increasing indexes with length k, such that the elements at these indexes are decreasing, and that means that we need at least k colors. So this is finding a decreasing subsequence, which is why I thought of the dynamic programming solution for the longest decreasing subsequence in an array. So basically, I sweep from right to left, and then dp of I stores the maximum length of a decreasing subsequence we have processed so far that starts with an element I. So in order to transition, you basically look at all of the characters which are less than the character at element I, and then we take the max of the dp of j plus 1. Then that will get us the maximum length of a decreasing subsequence which starts at I. And then we need to set, then that length will be the answer, that will be the color for the element. So for example, in the same example here, at element C, the maximum length of a decreasing subsequence starting at C is 1. So the color of C will be 1. And then for this element here, the maximum decreasing subsequence is DC, so we set it to 2. And then for this element, it is 3. For this element, it is 2. For this element, it is 1. And it's also 1 for all the elements before it. So you can check that this answer works for the given example. And that's basically it for problem E. And for F, basically for F, we start with the condition that all of the edge weights will be 1. Then when we are given a condition that the minimum beauty along the path from node A to B is G, then we need to update all edge weights with a path to be at least G. So here, basically in this DFS, I find the edges which form the path, and then I basically set the edge weight of the weight of the edge to be the maximum of the original weight, and the G which is given the query. So then, after I process all of these paths, I need to check that the answer that this algorithm gives it actually gives the correct answer. So I need to go through all the paths again, and I calculate the minimum for each path, and if it's greater than G, then there's no solution. Otherwise, if the calculated solution works, then I just print it out. And that's basically it for F. I don't know if I'm still third. Okay, 7th is not bad as well.